Okay, guys. I I don't think I'm gonna make long videos because I've actually made a couple so far. And they tend to crash, and then I lose everything. So maybe I'm just gonna keep my videos to maximum like 10-15 minutes. And then save and then make a new one. So you're gonna have um a couple of links or so instead of having one big video because it's kind of risky. So first of all, thank you so much to the students who provided me with the feedback regarding my first tutorial video. There were some really good constructive feedback. So again, I'm doing this for you. So please feel free to send me an email. Um, and if you have any suggestions, I'm open to that as well. So apparently the sound wasn't that great on the first video. So I was using my AirPods, but I think they're not very compatible with Zoom. So what I've decided to do now is to get an iPad from the school, and I'm using this nice app called Notability, and I'm just using the built-in Apple screen recorder that let me down just a few minutes ago because I actually made a close to like an half an hour video for and it just crashed. Okay, so let me try this again. Um, I just want to go over this quiz. So this was given to you before the test. And on the test, I mean, it was not as well done as the first one because your factoring let you down. So I really want to um, help you with that going forward because we're going to have to do a lot of factoring. Okay, so the first question on the quiz is completing the square. You got a question like this on the test as well. So completing the square is not really related to factoring, okay, because it doesn't help you find the roots. What it does is it changes this quadratic function, which is in standard form, to vertex form. Now, I showed you another way of doing this, right? Which, in my opinion, is a better way because it's less confusing. But you still need to know how to do this because that's what the curriculum wants you to do, okay? So the idea is you have to focus on the first two terms, okay? And get rid of your A coefficient. So my coefficient over here is minus 3. So I am going to factor minus 3. So this equals to minus 3. So what do I need to multiply minus 3 by to get minus 3x squared? Well, just x squared, right? And then what do I need to multiply um, minus 3 by to get minus 12x? It will have to be plus 4, okay? So let me just remove that. So plus 4x minus 22. So let's just keep the minus 22 on the side. And now your goal is to find, once you have this stuff inside your bracket, your goal is to find a binomial squared that will best approximate this, okay? So your binomial will always start with an x, and then you have to look at the coefficient of your x term and divide that by 2. So because it's plus 4 divided by 2 is plus 2. Then you square this, and when you square this, you will see that you're going to get the same two terms inside your bracket. So if I square x, I get x, right? If you square this x, you get x squared. And then you multiply this x by 2, so that's 2x, and then you multiply the whole thing by 2, so that becomes 4x. But then you have this extra term. So when you square the constant term over here, which is plus 2 squared gives me 4. So I can actually replace what I have inside the brackets over here by this, and I'm going to do that in the next line. So this just becomes minus 3 square brackets, oops, x plus 2 squared, right? So I have just replaced this term here by that, but when I do that, I'm actually adding this 4 that initially wasn't there, so I have to remove that. Okay, so let's remove this, minus 22. Now you will always have to remove something, because regardless of whether this constant term is positive or negative, when you square it, this will always be positive. So that means over here, you will always be removing it, okay? And then finally, once you have this, all you have to do is just distribute the minus 3 to each term inside your square bracket. So that gives you minus 3x plus 2 squared plus 12 minus 22. And then you can simplify these two, right? You can combine your constant terms together. So your final answer is minus 3x plus 2 squared minus 10. Now on the quiz, this question, on the test, this question was fairly well done. The only issue was I actually made this question a little easier, but for some of you it became a little bit more challenging because the constant term, right? There was no constant term, it was just 1. So when it is 1, then you don't have to do this first step, right? You don't have to factor anything. You can just proceed to um, the second step. But some of you, for whatever reason, factored x, right? Your goal is not to factor x, your goal is to factor whatever the coefficient is. Okay, in this case, your coefficient is negative 3, but on the test, your coefficient was just 1. Okay, so if it's 1, there's nothing to factor. So let's move on to the next question. Now here, you have to be careful because not only will you have to factor, but you will also have to solve, okay? So how do we distinguish factoring from solving, which some of you um, have a hard time doing? If I remove this equals to 0, then you will only have to factor this equation, okay, because there's nothing to solve. But because we have this equals to 0, then you will have to factor, okay? So how do you factor? If you have 3 terms, Um, try to find the GCF. Try to find something that is in common first before you proceed. But in this case, there's nothing. Okay, because my coefficient over here is 1. There's no number that can divide 1, negative 14, and 40 besides 1, right? So I cannot really factor a number on the outside. And only 2 of my terms have an x. So I can't really factor my x's either. Um, So that means I'll have to rely on the product sum method. Okay, so remember, quadratic equation is ax squared plus bx plus c. So you're looking for two numbers that multiply to a times c and add up to the b coefficient. Okay, so in this case, my a value, if it's not visible, it's 1. So I'm looking for two numbers that multiply to 1 times 40, which is 40, and add up to my b coefficient, which is minus 14, okay? And this is always the case, okay? It's always two numbers, their product has to equal to a times c, and the sum has to be the b coefficient. So because 40 is a positive number, right? This 40 is a positive number, then that means either both of my numbers have to be positive or both of them have to be negative. Now, because my b coefficient is negative, that is a good indication that the only way that this is possible is if both my numbers are negative. Okay, so yeah, to find the combination, I mean, you guys weren't too bad when it came to finding combinations. So it was just minus 10 times minus 4 minus 10 times minus 4. Now remember, guys, because the coefficient is 1, okay, you don't have to rewrite this 14x as minus 10x minus 4x, you could, but because the coefficient is 1, you can use a shortcut which tells you to put the x value, and then you look at the first number, it's minus 10. So minus 10, right, close the brackets, then you put your x value again, then you look at the second number, which is minus 4, right? So I factored this into that, but remember the whole thing equals to 0, right? So now we have a product of two terms that gives me 0. So let's just call this A, and let's just call this B. So we have A times B is equals to 0, right? That's the whole point of factoring, to change this um, subtraction and addition into multiplication, because multiplication helps us find the roots, okay? So if A times B is equals to 0, there's only one possibility, well, two possibilities, right? Either A is equals to 0, so either x minus 10 is equals to 0, right? So that means x has to equal to 10, or x minus, so either A is equals to 0, right? Or B is equals to 0. B is x minus 4 is equals to 0, and then you just solve for x. So x is equals to 4. Now, what does this mean? This means that if you replace this x value in your equation, then it will give you 0, right? So you've actually found the x-intercepts, or the roots of this function. Now, the second question, a little more involved, because first of all, there is a problem, right? I have an equation, but it's not really equals to 0. So you could either move your 6x squared to the right, or move this 13x plus 5 to the left, and get the 0. I like to keep my um, A coefficient positive for whatever reason. I don't know why. I just like this to be positive, so I'm actually going to move them to the left. Okay, so this just becomes 6x squared minus 13x minus 5 is equals to 0. Again, guys, it's just a question of preference. You could have moved your 6x squared over there, it would have still worked. Okay, now guys, because my coefficient is no longer 1, I cannot use a shortcut here, okay? But I will use the same product sum technique. So I'm looking for two numbers that multiply to A times C. So 6 times negative 5, that gives me negative 30. And they have to add up to my B coefficient, which is equals to negative 13, okay? Now, because 30 is a negative number, that means one of my numbers has to be positive, the other one has to be negative, okay? So automatically negative 10 and negative 3, even though they satisfy this equation, is not the right combination, because negative 10 times negative 3 is actually 30, not minus 30, okay? So, so again, the idea is you start with 1 times 30, that will not work, then go with 2 and 15, okay? So 2 times 15 will work over here, because because this is negative, right? So one of these numbers has to be negative. So because the sum is negative, then the bigger number has to be negative, right? So 2 and 15 is the combination that works. Now, all you have to do once you find the combination is to replace this minus 13 with the combination, okay? So I'm going to rewrite this as 6x squared plus 2x, right? I'm just replacing this minus 13x in an intelligent way. So the 2 comes from here, minus 15x minus 5. And again, the whole thing is equals to 0, okay? So plus 2x minus 15x is still 13x. So I haven't changed anything. I've just rewritten it in an intelligent way. And the advantage of doing that is once you have 4 terms, then you can use a technique known as grouping, okay? Grouping tells you to target the first 2 terms because they will always have something in common. So what's the biggest number that divides both 6 and 2, well, it's 2, right? And because the x's are repeating itself, right, there's an x squared here and an x there, you have to um, look for the lowest exponent, right? So the lowest exponent here is 1, so you're going to have to factor x, open the brackets, and ask yourself, what do I need to multiply this 2x by to get 6x squared? So 2 times 3 is 6, but then I need to multiply this x by another x, right, to get the x squared. And then what do I need to multiply 2x by to get 2x? Well, just 1, right? Now, once you have this term, for this to work, you should get the same thing up here. So let's just copy this, okay? So what do I need to multiply 3x by to get minus 15x? So the answer is minus 5. And let's check. Does minus 5 times 1 gives me minus 5? Yes, it does, right? Minus 5 is up here. Sorry, it's getting a little bit messy. And the whole thing, again, is equals to 0. Now you have to ask yourself, what do you see in common in this line? Okay, what is repeating itself? So as you can see, there's a 3x plus 1 over here. There's a 3x plus 1 over there. So you're going to have to factor that 3x plus 1. And let's do that. I'm actually running out of space. So we're going to have to squeeze this in. So if I factor 3x plus 1, that leaves me with 2x minus 5. So let's put the 2x minus 5 over here. And again, the whole thing equals to 0. So you've factored, but now you're going to make use of this factoring and decide what your x intercepts will be. Okay, so remember, you can treat this as your a value, right? So this is a, and this is b. So a times b is equals to 0, which means that either a has to be 0 or b has to be 0. So either 3x minus 1 is equals to 0. And when you solve for x, right, you're going to move the 1 and then divide by 3. So x has to equals to 1 over 3. Or either 2x minus 5 is equals to 0. So that means if you solve for x, right, move the 5 over, divide by 2, x is just equals to 5 over 2, which is 2.5. But, I don't really need the decimal value. So actually, I'm going to stop here because I'm afraid that this might crash again. And then I'll continue with the next page in a new recording. Okay, so let me just stop here and then I'll continue.